Okay, so there won't be too much going on with the assembly, so we'll go ahead and make it a metric assembly. And the body is open, so we can should be able to pick, make sure it's highlighted. And when I pick OK, it's going to go origin to origin. Okay, so we saw the two origins, and I can go ahead and hide those. And then we'll insert component, existing part in assembly. Pick your favorite method of inserting a new part, and we'll bring in the hex bolt. And right now the hex bolt is still being shown with its solid thread and default. So I did not pick. So I have two configurations, and I can right click, and at the very top I'm just going to switch these back to default for now, make it a little bit easier to work with. And if I control select the two cylinders, that will be concentric. I do want it to be able to rotate for our illustration. Let's go ahead and pull out the feature tree a little bit, and I'll expand the display so that the body then, let's go to hidden lines visible. And now I just want to kind of check those depths. So if that's sitting there and that's sitting there, apparently the 4 millimeters is what I missed last time. That created that little bit of an offset. So if we were to do the math, we'll probably come up with a number, but instead I'm assuming that the screws are to align, but really with a 5 millimeter, a 5 millimeter groove and a 6 millimeter. Yeah, I don't know that makes much sense to me. So having the 6 millimeters set in that 5 millimeter without some kind of geometry on the end doesn't really work. So let's just go ahead and select and control select. I'll put a distance. We'll start off with 1 millimeter and go back and double check. All right, so that looks pretty close. It's going to be kind of an adjustment. So we certainly have more thread than what we need down here. And again, if I have more information as to what this does, then that would be helpful. All right, so if I go back and I switch to the solid thread, and then right click again and switch to the solid thread, make sure to hit the checkbox. We're going to be able to see those threads. Now getting those threads to align is kind of a challenge. They don't really, it's not really like there's an alignment between those two inclined helical planes. So, we get something that's close, it looks fancy, but for our purposes, it's really not a mechanical fit. All right, so let's switch back to the default display, and then I will collapse. And in our toolbox, we have under the design library, if the toolbox is not loaded, I don't recommend loading it every time. If you're doing a lot of assembly, we can set it to in the add-ins to load when SolidWorks launches. Since we're not using it maybe all the time, we can add in now, or in the SolidWorks add-ins tab, if you still have that showing up under the command manager, you can click it in there. And there is another set of tools for calculating O-rings or calculating retaining rings and like. So we're going to go to the Ansi, well, I did Ansi inch by habit, so let's go to the Ansi metric, bolts and screws. We have a hex head, and I am not familiar with all of the designations, but it'll tell us pretty quick. Hex cap screw, hex bolt, so I'm going to assume it's a hex bolt. I'm going to zoom up on this to where I can see it. And if I drag to that point, it says there's no matching size, which is fine. our callout is an M6x10, so we want to go to an M6 length of 30. Well, that doesn't help me. So I'm just going to cancel out of there and see if we can find something different. Hex cap screw. So let's try that one. M6x10. That looks pretty good. In place. Alright, so we're going to get the concentric. And since it says you put in one, you must want to put in another. So we'll go ahead and apply. I'm looking for, I call them the stack of marshmallows, but those two cylinders are going to apply concentricity. And now that I'm done, I will X out of that. Maybe we'll go to the flyout again and hidden lines visible. And that way we can see how those engage. But if we're expecting it to contact on that surface and lock it in place, that's really not going to happen with the size of those grooves. So that being the case, we can get it close. I would like to have something a little more functional as far as a mate to keep it in place. So from the right plane to the bottom of the hex, and the assembly to the paper clip to the mate since I missed it, and we'll just go to the distance. Alright, so it wanted to go coincident, so we'll just make it 20 and accept it, and then the right plane and rotate over. And even though I can see the bottom through the hidden lines visible, I want to rotate enough to where I'm not picking on that cylinder, that I'm actually picking on that bottom surface. Distance and 20, and we'll go ahead and accept it. And I don't care if they rotate, so I'm not going to worry about the lock rotation. All right, so definitely some interesting issues with this part up for design review. So next, let's go with the exploded view in the default. Now, this would be a good place to set our configuration. So if I were to go to add configuration and do the solid threads, it's going to copy this over. I'm not making separate parts, so I'm not real concerned with the naming and the other data that's attached to that. So we'll go back over to the default, make sure that I have those, and we're going to switch back to, and because I have a configuration now, I also have this configuration, all configurations are specify. So I'm going to go back to the default, and then back to the default, and apparently I did not hit my checkbox. Okay, so now when I look at those, I have that simplified thread form. Looks pretty good. We can go ahead into, let's just do the assembly exploded view, and we're going to bring this one up. And I didn't hit the right mouse button for the done, so I've got to go over. This time I'll do the right mouse button, or rotate over a little bit, and pull it out, and right mouse button. Alright, so if I go back through each of those steps, now I can refine that distance. I like easy, clean numbers. So we want 30 there, then I can do 30 on the other side, and that'll give it kind of some symmetry. And then if we want to do the exploded lines, I don't know that helps having the lines go through there, so let's just take a look at it real quick. Exploded line sketch from cylinder to cylinder. I think with the kind of the fish mouth of the cylinder going through in the other cylinder. Okay, and then it picking the edges isn't as clean. And don't really want to jog, so not sure what it picked up there that it felt like it needed to jog. Oh, it started at the top, and so if we reverse that, okay, so notice how it does that little loop. So we'll make sure that that is selected, and then I'll reverse it and turn off the along. So got a couple of options there that we haven't really explored. And we can go ahead and do that. So those are going all the way into the part. Probably don't need to do that. We can clean that up by editing the sketch and dragging those lines, but I think that still looks pretty good. All right, so the test then is to go back and double click or right click and collapse, or in this case, since we collapse, we want to explode and collapse. All right, so the other thing that I would like to prepare is a visual cutaway. So let's go ahead and I'm just going to give it the project name. Make sure to save it. So in the solid threads and the visual, and we can manage this visibility with display states as well. So maybe I'll do that as an add-on video, but the display state has that ability to control whether this is solid or hidden lines visible. Right, so in our geometry, we can open up an assembly sketch, and I'm going to go to the right plane. No, that's probably going to need to be perpendicular, so my cutting tool is going to go this way, and it's going to cut through the part. So yeah, I need to be on the top plane. And we're going to generate a line that goes through the part. And we'll go back to isometric and accept and accept. All right, so with sketch 1 selected, and in the assembly, we're going to create an assembly as soon as I find it. An assembly feature that is going to be an extruded cut. We do not want this to migrate back to the parts. So this is going to be a through all. We're going to flip the side to cut, so that little arrow is showing me that direction. All components, and then propagate feature to parts. No, we're just going to perform this cut for the drawing. All right, so the cut extrude, and really as far as this for the solid threads, I don't need it to do, I really don't need it to do anything else. The other thing is if I wanted to show this as the whole, we could go back into that extrude cut, and so this is this configuration. Make sure it doesn't do it in the other one. We'll go down to selected components, and then that should give us the ability to pick. We want the external, but I'm not seeing that that list. So now just real quick check, get out of it, get back into it. Just for this configuration, collapse that. Okay, so the hex bolt is the one that I want to leave complete. So it kind of details how it's being engaged. We'll go back to the default state and kind of see that as the whole and its engagement into the other parts. So gives us a couple of options. We can double check the default, double check the explode, and then double check for the solid threads. All right, and then one more save, and we're ready to work on our drawing.